Today's question is, what if you built a tower all the way to space? Let's try to imagine it. First, we need to define where space actually begins. Most scientists use something called the Kármán line, which is about 100 kilometers above Earth. That's already much taller than anything humans have ever built. The tallest building in the world, the Burj Khalifa, is 828 meters tall. If you stacked about 120 Burj Khalifas on top of each other, you'd finally reach space, which already sounds slightly unstable. But the real problem isn't height, it's weight. Every meter of tower has to support everything above it. I tried estimating the forces, and the numbers get ridiculous fast. Even if the tower were made of steel, once you reach a few kilometers tall, the bottom would be under such enormous pressure that it would start to crush itself. Basically, the tower would collapse under its own weight long before it got anywhere close to space. But let's say we ignore material limits and imagine we had some absurdly strong futuristic material. Now we can actually build it. At first, things feel pretty normal. You take an elevator up a few hundred meters. The view is amazing. Planes fly below you, but once you reach about 10 kilometers up, you're already above most airplanes. The air is thin. The sky starts getting darker. Temperatures drop below minus 50 degrees Celsius. At 20 kilometers, weather balloons usually pop because the pressure is so low. Your tower is now sticking through most of the atmosphere. By the time you reach 50 kilometers, the sky is almost black, even during the day. And here's the weird part. Earth is rotating. At the equator, the ground is moving sideways at about 465 meters per second. That's roughly 1,670 kilometers per hour. Your tower is attached to Earth, so the top is moving sideways too. But because the top is so far from Earth's center, it actually wants to move even faster, which means the tower is constantly being pulled sideways by enormous forces. I tried estimating the sideways stress, and it would likely snap most imaginable materials. But suppose it somehow survives. At 100 kilometers, you finally reach space, step outside, and you'd technically be an astronaut, just standing on a balcony. But the tower would face another huge problem: satellites. Low Earth orbit satellites pass overhead at around 7.8 kilometers per second. That's about 28,000 kilometers per hour. If even a small satellite clipped the tower, the impact energy would be comparable to a massive bomb, and statistically, that would eventually happen. So a tower to space might sound simple, just keep stacking pieces upward. But once you start adding up gravity, pressure, Earth's rotation, and orbital debris, you realize something strange. Getting to space isn't hard because it's far away. It's hard because Earth really doesn't want tall things sticking out of it.